So we've just done our t-test for whether pulse is different for the two genders. And now we want to answer the first question. So back in our Word document, it asks us, is the difference in pulse between males and females statistically significant? So as I alluded to briefly in the last video, if the p-value is low, then the null hypothesis has to go. So our null hypothesis is that the pulses are the same for both the gender groups, for both females and males. So our p-value was very high. Let's come back to R to remember what that was. Our p-value was 0.682, either over here or printed out for you here. So our p-value is not low, so our null hypothesis cannot go. So we conclude that there are no significant differences in gender. So you can just put that in your Word document. You could write that, and or if you wanted, you could have put it here. It probably is a good idea to comment it out. That little symbol there just means that if I ran this, it basically runs nothing. It actually goes to the next line of code. So what we're going to do now is look at whether this pulse is normally distributed or not. So we've done a histogram of the pulse, and it looks like it's not perfect. You know how we normally have a bell-shaped curve that in the centre was a bell? We look like we've got a bit of a truncated or a thing that's leaning up against top, that there's a certain level of pulses, and we don't tend to get ones higher than that. Let's have another look at another plot. This is the qqplot, which we mentioned in our lectures. Helps you look at whether it's normally distributed or not. So ideally that qqplot would be a straight line. For the most part it's near that straight line, but near the top here you see there's some departures from normality. And if we run a test, the Shapiro Wilks normality test, it gives us a p-value here in a test. That p-value is very low. It's got 5 zeros before our first one. If we did 0.000001 would be our answer, so it's very low. So our null has to go. In this case, our null is that it's normally distributed, and our alternative is that it's not normally distributed. So we'd say that this is significantly not normally distributed. So our next question is, was the t-test appropriate, or was the Wilcoxon rank Mann-Whitney test more appropriate than non-parametric? So we'd see there is some departure from normality. So the Mann-Whitney or the non-parametric test, let's call it Mann-Whitney, may be more appropriate. Unfortunately, maybe I should have done that in Word. One of the reasons I like to write it in Word as my answer is because it corrects my spelling. So the answer that I just did was that, and you see another typo that I did. Maybe I should, if you want to, you could highlight your answers so that you'll find them quite easy when you come back to them. And we missed the question here. The first one was underline the correct statement below. So we saw there was no real difference because of our very high p-value for our test between genders. So then we would say that there was not a significant difference. So if we wanted to, we would highlight that one to say that this is the answer to the previous question.